Hello Exocad. In this course we're going to design an upper denture using the new updated release, release candidate version 2.4 of the full denture module. To begin, we're going to start DentalDB. This is the release candidate version, the beta version, so it may not be exactly like the release version 2.4, but in general, the major workflow steps are going to be the same. We define our job. And we are going to define an upper denture. And you can see first right away when we select full denture for our material, we have 6 material selections and combinations. We can mill the base or print the base, and we can mill the teeth, print the teeth, or use denture cards. So you can see here these 3 options here have preformed denture teeth. The top and bottom right options have milled teeth, and this lower left corner is printing the base and the teeth. For this course we're going to print the base and the teeth simply because that is probably the option that most dentists are going to select, making these in their office. Here are the options and parameters we have for a full denture definition. We can scan a pre-op model. I'm going to say no. We can scan a bite rim. I'm also going to say no with this because I don't have a bite rim scan. We're going to use just an upper edentulous jaw and lower antagonist scan. We have the option to use scalable tooth libraries with the denture, so our options are optional, yes, and no. So I'm going to select yes, allow scaling from initial placement. You can also change this later in the workflow wizard. And finally, design prosthesis with a monoblock try-in. You can choose yes or no to merge your design into a single STL with teeth and base, or remain separate base and individual teeth. So for this we're going to say no, as we're going to print the teeth and base separate. And do we want to optimize the monoblock for 3D printing? Again, if we're not designing one, it doesn't matter. And our minimal thickness here, you can't see because my screen resolution isn't big enough to show the minimal thickness, so we're just going to leave that at the default. And we can select the advanced parameters if you like. These are the connector shape, dimensions, and cross-sectional area of the connectors, the connector height, width, how far we're going to allow design below the gingiva, and design of connectors on the lingual of contact areas. For dentures, we have a tooth pocket gap. Now you can't see what this is. If I resize it, I can, but I can also change this in the wizard. So we'll show you what the tooth pocket is. I don't need to define it for all of the teeth, but I will, and you can also determine if you would like connectors with your teeth. The default is to have no connectors, to have each individual tooth. Now I'm going to define an opposing antagonist, and I'm just going to define that single tooth 27. I'm going to skip the virtual articulator and just say that these scans are in occlusion. that is enough for designing or defining our job in DentalDB, so we can save our project and move forward with design. Now I have 2 scans ready. I'm going to go on my desktop and load the upper jaw scan and the lower jaw scan. And the first step in the wizard is to adjust the scan data orientation. So I'm going to try and define an insertion axis here to eliminate undercuts with a denture. So I'm going to say right about there. And we start the model analysis wizard. So we're going to start the model analysis now. Now the issue with an upper denture is it is going to define the occlusal plane using the lower teeth because I have that as an antagonist. You can see I only have a partial scan here. This patient does not have molars. So we're going to define by 3 points. Click that, and our box comes up left, right, and center. So I'm going to click the occlusal plane on the patient's left premolar, then the right premolar, and then the center in between 24 and 25. And so that will generate our occlusal plane. Going to click OK to exit the occlusal plane window, and then click Next to move forward in the model analysis. We're asked to define molar points here. I don't have them, so I'm going to click Next and define first premolar positions on the lower jaw. Begin with doing the left premolar, and then the right premolar. Click Next to go to the next step. Now we're going to mark the mesial contact area of the central incisors on the lower jaw. Our mesial contact area is right here. And because I skipped a step, I skipped the molar position. I need to go back to that step in the model analysis and put molars here, again left first, and I'm going to go just as distal as I can on the scan that I have. This will create problems later on, but we'll be able to easily fix them. So now I can click Next and auto detect the midline or the median plane on the lower jaw. I'm going to turn on the upper jaw scan so we can see where this lies on the upper jaw. And while I like the midline, I don't like the trajectory. So in order to rotate this plane, I'm going to hold the control button and rotate the plane a little bit, and then move it back by letting go of control to where it goes through my contact area. So that's how I rotate and move. I like this midline. So now I can click OK to exit model analysis. Now we can move on to the next step in the wizard. Here is our tooth selection, our tooth set selection, and you can see immediately what our problem is by having first molars that are too close, okay, that aren't in our scan. Our posterior set is very small. So we can change that by making these teeth scalable. So in our library filter, we have only scalable selected, and we can choose which shapes we would like. If we would like an Exocad generic XXL, we have Nobilian NobleDent 30, 32, 34, and 36 for posteriors, and we have the Tribos series denture teeth as well. So we have summaries here in the drop-down window. I'm just going to keep them as Exocad generics. I prefer never to place second molars, and we're going to optionally scale scalable teeth. Keep that option selected. We can place the posteriors, place the anteriors, and we can move forward with the next step in the wizard, and we will change the size of our teeth. Now we're in the tooth placement step of the wizard, and this is just like tooth placement step in other wizards, other workflows, but we need to resize our posteriors here. So I'm going to lock the teeth that I don't want scaled, and because the first molar position is too far anterior, I'm simply going to drag the distal contact disc posterior until I have the correct size of posterior teeth that I would like. So maybe that size. Go around to the other side, grab the distal contact disc, pull it back, and enlarge those teeth. That may be appropriate for this patient. If you have a full lower jaw scan, those teeth will come in appropriately sized. So now we can use chain mode to resize and place our teeth. Just like in anything else, we can lock the teeth, move them along the chain, hold Control to rotate and move along the chain. I want to bring that up. Locking the teeth with those control buttons, those control spheres, those control circles, the green and red circles. Because I don't want to resize all of the teeth along the chain, I just wanted to tilt this tooth number 12 and now raise up tooth number 13 and maybe raise up tooth number 14 without angling it. If I like where those posteriors are, I can unlock from the canine, or maybe just lock the canines, but unlock the canine and lock the first premolars, and I'm going to bring these anteriors in a little bit, make them a little bit smaller. And I like that position. So this is just getting used to using chain mode and resizing and positioning teeth in general. You've done this several times before with other Pontic definition designs. But this seems good now. So we can turn on our jaw scan to see where we are in relation to the soft tissue, if we want to make any changes there. But for now, we're going to accept this and move forward in the wizard. We have the freeform step now, and if some teeth are sticking out, what I like to do is go to Adapt, and keeping everything in place, in the freeforming step, we can adjust the occlusion if we would like. So let's say we don't like these heavy intrusions here. We can go to Adapt and cut the intersections of the occlusal surfaces. Now our occlusion should be right on. And we can adjust the approximating surfaces between all of these teeth. If I'm using chain mode, I'm not altering the contact areas at all, so I won't need to do any adjustments of the approximating surfaces. When I've gotten to this step, it's pretty much straightforward to go next to design our virtual gingiva, or design our denture base. Now, we have an insertion axis here, and you can see the undercut is in purple, and I want to eliminate more of that undercut, so I'm going to change the insertion axis to about here. We have properties of the blockout and offset. We have a 0.03 millimeter offset. This is going to be the distance between the edentulous jaw and the denture base. An offset angle if it's coming straight off of the surface or coming out at an angle. And how much of an undercut are you going to allow to design into your denture base? This we have 0.1 millimeters as the default. And then finally the surface properties, how much are we going to smooth, and the milling diameter. If you're going to mill your base, you want the milling diameter to be the diameter of the smallest milling tool that you're going to use when milling the base. So I like this angle, I like the block out properties and undercut values, so I'm going to click Set Insertion Direction from View. You can see the arrows now change. The blue are the previous insertion angles, and now green is the current view, and now I'm going to apply. Now the bottom surface has been generated. We get a light blue color that we can freeform. We can make the surface smoother if we would like. But I don't make any changes personally. I just move forward and click Next. And we can design our denture base. This is just like virtual gingiva, and we're going to select the extent of our denture base. So this is the denture periphery. And I go right to the edge of the undercut in green. And make some cutout for little bit more comfort for some muscle attachments. And click Next. We're now in the freeform denture base step. This is just like a freeform gingiva step where we can use virtual wax to add, remove, and smooth the virtual gingiva or the denture base. We can also use rubberized tools, push-pull, using large denture base parts and the entire denture base. So this is a small part, like we want to add more papilla, push-pull papilla, or an entire section of the denture base. We can also use the freeform tools to add virtual wax, maybe add some necks around the free gingival margin. If you would like to add a periphery to your denture, you can do that here. But this is the step where you can characterize your denture base. It's important to note that the denture base should go all the way around your most posterior tooth. It should wrap around the distal of your most posterior tooth. And the denture base should be touching the denture tooth. The tooth shouldn't be floating without virtual gingiva or without denture base touching it. Otherwise, you'll have some problems going to the next step. So that's it for the freeform step, where we can characterize just the pink area of our denture. We can go to Next and move forward in the wizard. Now we're going to adapt the base to the teeth. We have a couple options here. This is the option that you didn't see before in Dental DB, the tooth pocket gap. So we have a minimal thickness for the denture base of 0.5 millimeters, and we have a tooth pocket gap of 0.3 millimeters. This is going to facilitate inserting the denture teeth into the base. If you don't have a sufficient pocket gap, there is not going to the denture base is going to fit too tight, and you won't be able to insert the denture teeth. I found a tooth pocket gap of 0.3 millimeters to be sufficient for easy insertion and having a single insertion axis, so you can put in all of the denture teeth in one. You can print out the whole arch and insert it all in one piece. We do want to block out tooth pocket undercuts. You can limit the material insertion angle for milling if you check this box, and you can compensate for a milling head. What this means is that Exocad will take into account the diameter of the milling tool that you're using if you are going to mill the base, and make those tooth pocket internal angles not as tight, so your milling tool will be able to get in and mill the pockets appropriately and allow enough room to insert the denture teeth. Since we're printing the denture base, we don't need those options checked. if we're happy with our minimal thickness and our tooth pocket gap, we can click Apply. Now that Exocad is done determining the tooth pocket gap, we can click Next. That is the final step of the denture wizard. I'm going to turn on the denture bases and turn off the bottom surface and show you what the denture module did. You can see in this cut view, this cutaway view of the tooth, that we have a gap in between the tooth and the denture base. That gap is 0.302 millimeters across, 0.3 millimeters all the way around. So there's a 0.3 millimeter space in between the tooth and the denture base, as you can see where this window is, right in the middle of number 9. You can also see that our offset between our jaw scan and our denture base, our jaw scan is this beige line, the pink line is the denture base, and that gap is 0.03 millimeters. So just as that is our offset when we are making the bottom surface of 0.03 millimeters and our pocket gap of 0.3 millimeters. So zoomed out, it looks like they're just touching, but you can see what zoomed in, that there is a very, very slight gap between the edentulous surface and the denture base. And then you can see our 3 millimeter tooth pocket. So now we are ready to print the teeth and the base separately. And I will show you the files that Exocad creates. So here are all of the teeth. You can see the tooth preview on the right. There's all of the teeth in their spatial orientation. So if you bring all of these in together into your CAM software, your printing software, all at the same time, or merge them, you can merge them using Mesh Mixer and save them all as a single STL and print as one. Or you can save right from Exocad. But you can see here that we have this named file, prosthetic base. This is our denture base. I'm going to show you how to save those files in Exocad. I'm going to close Cut View. I'm going to uncheck denture base and I'm going to uncheck jaw scan, and the only thing I have selected is anatomic shapes. You can see here in the show hide window I have all of these tooth shapes, and you can see that Exocad did the appropriate job of cutting away the base of the tooth where it interfered with the denture base or didn't give the denture base a sufficient thickness and didn't intersect with the jaw scan. So Exocad took care of that for us automatically. With only these showing, I'm going to right click the desktop or the workspace, save scene as, and make it an STL. I'm going to put it on the desktop and I will name it denture teeth. Save the visible objects only, yes. and I'm going to use the default coordinate system. Now I'm going to come over here in the Denture Bases menu and the sub-menu item Denture Base Adapted. I'm going to check that and hide the anatomic shapes. This is already saved as our prosthetic base, but you can see that STL, our denture base, will print with the tooth pockets, and you can see the tooth shape in that tooth pocket there where Exocad altered the distal of that molar. But this is what our denture base will print out as. This is in the saved file, but again, with just the denture base showing, we could right click on the workspace, save scene as, STL, then I'm going to put it on my desktop as denture base. So that's it for the denture module. What I'm going to show you is what, when I save all of those denture teeth, I saved denture teeth.stl on the desktop, and we're going to open that with Mesh Mixer, and I'm just opening one file. And you can see that it is one file with all of the denture teeth together. So I can just print that one STL file, and that will print the full arch of denture teeth. I can also bring in our denture base, and you can see it fits perfectly with our denture teeth. So thank you very much for watching this new denture course. Hopefully the new release will allow you to print dentures, immediates, conversion dentures much easier than the previous workarounds that we had to use. As always, if you have any questions, please email me info@exocademy.com. Thank you again. Have a great day.